We'll see about static storage class specifier. Now, static storage class specifier, its life is throughout the application. When a function has been called for the first time, assume that the static variable has been created inside function, and when you call that function for the first time, the variable gets created and initialized. Okay, only for the first call, the variable gets created and initialized. And when you come out of the function, the value and the variable both will be retained in a random access memory. That means when you come out of the function, as like your auto, the variable doesn't get destroyed, the value doesn't get destroyed. It will be preserved as. For the second time when you call the function, the variable is not recreated nor it has been reinitialized. That is, if you do a dynamic initialization, that creation and dynamic initialization both will be skipped. Okay, the creation and dynamic initialization is done only for the first call. So whatever the value was present when you come out of that for the first time, the same value you can it will be available for the second call. Okay. Second thing is, if you don't initialize a static variable, automatically the static variable will get initialized to 0. You need not initialize it, automatically it gets initialized to 0. Hence we call this as initialized variables. Static variables are initialized variables. Fine. Third thing is, the static variables are not stored inside stack as like an auto. Auto variables are stored inside an stack, whereas static variables are stored in an initialized variable area. I'll take an example and then explain you here. We'll have here a main function, and in this main function call and 3 times the display function. So let's call this display function 3 times, and here in the display we'll declare one static variable by giving it as static int x and do a dynamic initialization. Okay, fine. And we'll give here x is equals to x plus 5 and then printf %d, that is an x. Let's see what will be the output and how this program is going to work. So the program execution starts from the main, and from main you're calling this display function for the first time. So it'll, from this place it will jump to this for the first time. When it comes down to the display function for the first time, this x variable which has been declared as in static gets created inside random access memory, and that also inside an initialized variable area, whereas all auto variables are created inside a stack. Fine. So x has been initialized to an 1. If you don't initialize this, x will have a value as in 0, whereas auto variable will have a value, junk value, that is a garbage value, any value it may be. Whereas here, if you don't initialize dynamically, its value is going to be 0. And you have given here x equals to x plus 5, then this x value is going to be a now 6. Okay, and printf x, so that 6 will be displayed. And as soon as you come out of this function, this variable and this x variable and its value is been preserved as it is. It is not destroyed. Okay, so you'll go back to the main, and from main again, second time you'll again come back to this display. So when you come to this display, this whole line will be skipped. The whole line, that is creation as well as this dynamic initialization, is skipped, because the static variable gets created and initialized only for the first call. Remaining calls it will skip off. So directly it comes down here, x equals to x plus 5. So the present x value is 6. So 6 plus 5, it's going to be 11. So your x value, it's going to be nothing but an, so this present x value will be an 11 here. Okay, and when you say a printf x, you'll get the output as an 11. So again, when you come out of this place, still that x value is 11, it will be preserved as it is. Then again, from the main, third time you're going to call this display. When you come down again, this line was skipped. X equals to x plus 5. X present value is 11, so 11 plus 5 is going to be nothing but 16. So x value is 16, and printf x will get the value as an 16. So this is what the output you're going to have. So when you come out, still the value is preserved, and when you come out of the main, that time this whole x will be removed from the random access. That is, when you come out of the main, program, that means the application has been terminated, the program has been terminated. That time that static variable will be destroyed. That means the life of a static variable, is throughout the application. The scope is only within that function you can access. You can access that variable only within the function, not outside. And it has been automatically initialized to 0, and it has been stored in an initialized variable area.